All right, so with circumference and arc length, we talked about everything with in chapter 10 with the circles that dealt with its angles and for the most part the interior part of the circle. Now we're going to deal with the outside of the circle, and in this case the circumference and the arc length. So your circumference of a circle is denoted by the following two formulas. C meaning circumference, where you can either find it given the diameter or the radius. If you have the radius, you have to multiply that number by 2. If you have the diameter, you just multiply that number by pi. Then normally how we will leave this, so if it says the circumference of a circle with a radius of 9 centimeters, unless it tells you differently, leave it in terms of pi because that's the exact value. Okay, so if it gives you the radius, which of these two am I going to use? The first one or the second one? The second one, because it has the radius. Okay, so if I want to find the circumference of the circle, if the circumference is 2 pi r, the circumference is just going to be 2 times pi times 9, which is just going to be 18 pi. Again, leave it like that unless it tells you differently. So then here it says the radius of a circle with a circumference of 26 meters. So we want to find the radius here instead, and we're given the circumference. Now, in this case, you're going to actually get a value. So if we set it up, I'm just going to go 26 equals 2 pi r. So if I am even in this case, I'm okay with you leaving it as in terms of pi. So because pi is just a number, I'm going to divide by 2 pi. Pi's go away, the 2 goes away on the right side. What is 26 divided by 2? 13. So I'm just going to write it as 13 over pi equals r. Now, unless it tells you what to round it to a certain decimal place, then you will actually type in 13 divided by pi. Okay, but for right now, just leave it in terms of pi. Whenever we talk about the arc length, okay, the arc length, so you can't see what is in red, but you can tell that here. Okay, if I want to know what the length is, it's basically the easiest way you can think about it. It's like if there is a slice of pizza on a whole piece of pizza, okay, a whole pie. So basically, how long is the crust from edge to edge if we would cut it out? Now, you know that the full degree measurement of a circle is 360 degrees. So the arc length, okay, is going to be basically all this is just the formula for the circumference here, and we're going to take that proportion or that ratio of the angle that we are dealing with. Okay, it's like if we cut the middle from the middle out and we cut out this piece of pizza, pie, cake, whatever you want to think about that's circular. If you looked at it and you want to know how long the length is here, all you have to do, it's 360 degrees all the way around. You're going to take that arc angle, divide it by 360, and then multiply it with the circumference length. Okay, you're going to need to know what the ratio or what the radius is for you to be able to do this, or the diameter. Okay, remember you can use the diameter here if given of just the diameter times pi, if that is what's given as well. So if we want to know the arc length from A to B. Your central angle is 60. Your radius is 8. So all I'm going to do, if I want to know what the length from A to B is, I'm going to go 60 over 360 times 2 pi times 8. Okay, or I can call this 16 pi, either one. Okay, so what is 60 over 360 going to reduce to? 1 over 6. So 1 over 6 times 16 pi. It's the same thing as saying 16 over 6 pi, which is going to reduce how? What can I divide 16 and 6 both by? 2. So 8 over 3, or 8/3 pi. Again, leave it in terms of pi unless it tells you different. That way we don't have to worry. That is your exact answer. Okay? That way we don't have to worry about having a decimal or where to round, things like that. Okay? Unless it gives you, like on B and on C, unless it gives it to you as a decimal, then you're going to have to write it in terms of a decimal. Okay, but something like that, leave it in terms of pi. On the middle one, we want to know what the circumference is all the way around. So you can do this a couple different ways. Okay? The easy way, or at least the easy way that I think, is how many 40-degree sections of this circle can I have? 9, right? So how do we get 9? What do we do? There's 360 degrees of a circle. This section, okay, we kind of worked backwards. Okay, so there are 9 40-degree sections. So that means there are 9 lengths that are 4.19 inches. So what am I going to do with the 9 and the 4.19? Multiply it, right? So I'm going to take 4.19 times 9, and that's going to give me my circumference. Okay? We're all about working smart, not hard, right? That's the easiest way I can tell you to do it. Does everybody understand why there are 9 40-degree sections? Yes? No? Oh, I did write 6 instead of 9. There we go. So 37.71 inches is the circumference. It gives you a 40-degree section. It tells you that that arc length is 4.19. It's 360 degrees all the way around, so it's like if I would just keep drawing 40-degree sections, so on and so forth from there. I didn't do a very good job. There's 9, kind of. Okay, that means there are 9 40-degree sections, so I just took the 9 that I have, multiplied it by 4.19, and got my circumference all the way around. So we're given the arc length, we're given the radius. We want to know what the angle is from R to S. So remember, that angle is going to be the same thing as the angle that's through here. Okay, which is our central angle. So we can find, if it's 44 over the circumference of the whole circle. Well, what's the circumference of the whole circle? Or how do we find that? 44 is the part. The circumference is all the way around. We want to know the partial angle as opposed to the full angle of the whole circle. So how do we find the circumference of the circle? Two times 15.28 times pi. So 15.28 times pi, or times 2 is 44 over 30.56 pi. Now, this ratio has to be the same thing as whatever that angle is and 360. I basically did part of the circle over the whole circle, right? So from here, I'm just going to cross multiply and multiply 360 times 44 and get 316. What do I need to do with that number, that 316, to get x? Pi? Oh, I hit minus instead, that's why. Sorry. 15,840. My fault. Now, so if I have 15,840, I need to divide it by 30.56, and you can just type in pi. Don't change it to 3.14. Okay, you have a calculator. So change it to 15,840 divided by 30.56 pi. You may have to put it in a parenthesis, depending on your calculator, because if you don't put it in a parenthesis, you might get 16 or 1,628. If you put it in a parenthesis, you're going to get the right value of x equal to 164.99. Let's just go ahead and call it 165 degrees. Okay, so you may have to put this in parentheses when you divide it, depending on your calculator. So here it says the dimension of a car tire is shown to the nearest foot. How far does the tire travel when it makes 15 revolutions? So you've got a lot of information here. It says basically from your wheel in diameter is 15 inches. Okay, so if you're not fancied with cars or know what we're dealing with, the wheel is this silver shiny part right here, okay, that the tire goes around. So the radius of the wheel is 15. The sidewall of your tire, okay, and they call that the sidewall because it's like a wall and it's on the side as far as the tire. The top of it is called the tread. Okay, as you drive, the tread gets thinner, so actually the circumference of your circle or your tire will get smaller as you drive it, believe it or not. So we want to know, it says the dimension of the car tire shown, nearest foot, how far does it travel when making 15 revolutions? Well, let's just figure one revolution first, okay, to the nearest foot. So what is the actual length from basically edge to edge? How much? 26 inches. Now, how do we get 26 inches? Yeah, we added that number, and that number together. Okay, so the diameter is 26 inches. So with that, can we figure out how many inches or feet? Okay, let's just keep it in inches for right now, and then we'll convert it to feet in a minute. So if the diameter of the whole thing is 26 inches, what's the circumference of my tire? How far is it going to travel? If I put a pin or something, a line, and I roll it until it basically starts at the top or the bottom, wherever I start with it, until it ends up back where it is. That would be a revolution. Okay, wherever it started, it ends up wherever it finishes. So, what am I going to do with this 26? Multiply it by pi. Okay, so from there, the circumference around 26 times pi. Now in this case, since we're going to have to take it to the nearest foot, it's okay to basically put it in decimal form. So if I go 26 times pi, I'm going to go 2 decimal places and I'm going to say 81.68 inches. 26-inch tire from edge to edge actually goes 81, almost 82 inches. Okay, so a little over 6 feet. Okay, almost 8 feet, or 7 feet. Say that again. So 1 revolution is 81.68 inches. How many revolutions do we want to know about? 15. So what do I need to do with these two numbers? Multiply them. So if I take that number, I'm just going to leave it in my calculator and multiply it by 15. And I get 1,000. So with 15 revolutions, it figures out to be 1,225.22 inches is how far it travels. Now we want to know to the nearest foot. So what do I need to do now with this number that I just got? Divide by 12. Why 12? Because there are 12 inches in a foot. So divide by 12. And I get about 102 feet. I get 102.10176. So about 102 feet. Now, last one that we will talk about says the curves at the ends of the track are 180-degree arcs of circles. The radius of the arc for a runner on the red path is 36.8 meters. About how far does this runner travel to go around the track once? So you've got the blue that is the 44.02 meters. Let's actually put that one in blue. Okay, so the person that's running around, like if you run around, basically like run around lane 8 of the track, if you both start at the same position and one person starts in lane 8 and one person starts in lane 1, who's going to go further? Lane 8, right? If they don't change lanes, that's why whenever they run like the 200 or the 400, that's why they're staggered. Because one person technically gets a head start, even though their distance that they actually run is the same amount. If you've never been to a track meet, that's how it works. Or watch the Olympics, that's how it works. So we're only worried right now about the red line. Okay? So the red line that goes all the way around here, we'll say on lane 4, whatever. So if it makes two 180-degree arcs, if I would draw a line basically from here to here, and do it again, isn't it just going to make a circle here between my two halves? Yes? Makes sense? So if it's 36.8, what's the distance that they're going to travel around on the curves? Or how can I find that? What do I need to do to find as far as the curve? Yeah. So the circumference is just going to be, my radius is 35, so 2 times pi times r. Well, my radius is 36.8. So 2 times pi times 36.8. So the distance on the curve is 231 meters. 231.22 meters. Let's go with that. Now, it wants to know about one full lap. So did they go 231.22 meters? No, how far did they go, or what else do I need to do? 84.39, right? This value? Do I just do it once? No, it's also up here at 84.39 as far as their value. So I need to take these two values. So if I take 84.39 and multiply it by 2, I get 160. So I took 84.39 times 2, because there's a front straightaway and a back straightaway, and I get 168.78. What am I going to do with the two numbers that have the box around them? Add them together.
Don't you have to do the 231.22 again for the other side?
No, because it's a full circle.
Oh, okay.
Because it's a half here and it's a half there. So whenever I add those two up, how much do I get? 400 meters. If you've never been to a track meet or watched the Olympics on TV every 4 years, the track is 400 meters around. That's why a mile constitutes 4 laps, and then the 2 mile would be 8 laps, or the 3,200, or the 1,600 if we're talking about the mile.